Okay, we're on page 3. Question 13 at the start there. Write 7 root 14 as an entire radical. So if I have 7 root 14, I'm trying to bring the 7 inside. And when I bring it inside, I need to square it first. So 7 squared is 49. So that's the same as root 14 times 49. I got this 49 from bringing that 7 in, and as I brought it in, I had to square it. (14 times 49 is 686. So that's the same as root 686, which does show up as an option there. So C it is. Number 14, write 16 times the cube root of 3 as an entire radical. Same procedure as before. I'm bringing the 16 in, but this time I've got to cube it. So 16 cubed is 16 times 16 times 16, which should be 4096. So I'm writing the cube root of 3 times 4096. And 4096 times 3 should be big, 12,288. Yeah. Which, there it is, B. Okay, B. And I think that you preferred that method in class. Writing from mixed to entire. I think you liked that. It was a bit easier. 15 asks you to evaluate 125 over 8 to the power of 4/3. We could rewrite that as the cube root of 125 over 8 and all of that to the power of 4. The cube root of 125 over 8, 125 and 8 are both perfect cubes. 125 is 5 cubed, and 8 is 2 cubed. So we've done the cube rooting operation, and we still have this exponent left on the edge. So 5 halves to the power of 4, that's the same as 5 to the power of 4 over 2 to the power of 4. 5 to the power of 4 is 625. And 2 to the power of 4 is 16. 625 over 16 is right there, it's C. You could also, if it just says evaluate, there's nothing stopping you from just using your calculator and just typing in 125 over 8 to the power of 4/3. The problem is you'll get a decimal value unless your calculator is fancy enough. But you should be able to compare that decimal value against these decimal values, and you should be able to pick one that works. I always recommend knowing and practicing at least 2 ways to solve a problem. Focus in on one to get it rock solid, but have a backup. Question 16 asks which of the following is not equal to 625 over 256 to the power of -3/4. And that one asks you to check all of them, right? Well, 3 of them are going to be equal, and 1 of them won't. So 625 over 256 to the power of -3/4. We could write that negative exponent means we could just write the whole deal as the bottom side of a fraction, right? 625 over 256. And make that exponent a positive 1 to the power of 3/4. Could do that. But I mean, 1 over 625 over 256, why wouldn't I just rewrite that in a more sane way as 256 over 625, all of that to the power of 3/4. Because 1 over 625 over 256, I don't know if you've heard this phrase before, but in a situation like this, we can say the bottom of the bottom is the top. You can review why that would be the case by looking back in your notes from years ago to pre-algebra or earlier and looking at your rules for dividing fractions. You're multiplying by a reciprocal. If that's not familiar, work out an example. So we could write the same thing. So 256 over 625 to the 3/4. We could also write that in another way. We could write it as the 4th root of 256 over 625, and all of that cubed. So this, and pick a different color here. This both mean the same thing. And we could also take the 4th root of 256 over 625. Both of those are perfect 4th powers. The 4th root of 256 is 4. The 4th root of 625 is 5. And you can check those on your calculator. I don't expect you to memorize those. And if we take that and cube it, 4 cubed is 64. And 5 cubed is 125. So now we've got a third option. That is this one right here. So 64 over 125 shows up there. 256 over 625 to the power of 3/4 shows up there. And this thing that I don't even like shows up here. So I've written it a bunch of ways, and none of them were this. This one, this D, just didn't show up at all. You could also, for all of these, evaluate all of these on your calculator as well. Why not? Last one for this page. Paleontologists use measurements from fossilized dinosaur tracks, and the formula V is 0.155 s to the 5/3 f to the -7/6 to estimate the speed at which a dinosaur traveled. In the formula, V is the speed in meters per second, s is the distance between successive footprints, and f is the foot length in meters. Estimate the speed of the dinosaur when the distance between footprints, s, is 1 meter, and the foot length, f, is 0.65 meters. Those are shuffly little footprints for something with such big feet. That's a 65 centimeter foot, which is big. And their steps are only 1 meter, which is like a human. Well, whatever. I'm guessing it's just going slow. So we have our values S and F. Maybe I'll just give them some color here. F, and F, and S is 1 meter, and there's S that shows up there. So we're just plugging in the value, right? We're just using this formula and evaluating. So V is 0.155 times S to the 5/3, but S we know is 1. Oop, come back here. And times F to the -7/6, and F is 0.65 to the -7/6. So I would deal with my exponent term here first, and this term here first. It doesn't matter which one of these I do first, but I got to do one of them first, and then the other one, and then I'll multiply everything out. So I can say V is equal to 1 to the power of anything is 1. So I have my 0.155 there, times 1. That's this guy taken care of. And F is 0.65 to the -7/6. 0.65 to the power of 7/6 negative is 1.65, etc. It'll be a big mess. So we'll just multiply those out. I'll take that big mess, multiply it by 1, doesn't change, and multiply it by 0.155, and I get 0.2562, etc. And out of my choices that I can see here, this is the closest one, 0.26. So I would choose D. So all I did in this question was find my variables, plug in the values into the formula, follow my order of operations, follow BEDMAS, right? Do the exponent first, find what value that is, that's 1.65. Find what value that is, that's 1. This is just a coefficient, it's easy. And then multiply them all out, 0.155 times 1 times 1.65, etc., to get my final answer of close to 0.26. And 0.26 meters per second is slow. That's less than like a kilometer an hour. So I think that was a good estimate on my part. Okay, I'll switch to another video for the next